One of the most significant improvements brought with version 21 comes in the form of a security protocol for data encryption and authentication between the automation engine and some of the components like AWI, Analytics, and the Windows, Unix, and Java-based agents. Prior to version 21, some data transfers could be encrypted and most were optional. The TLS SSL protocol is now a de facto requirement, and we've streamlined the process considerably. In this overview, we'll explain the key concepts and provide a high-level view of the encryption and authentication infrastructure. We'll also show the impact of TLS SSL on each component. The purpose of TLS SSL is to ensure privacy by encrypting data and verifying the identity of the parties using public key cryptography and certificates. If the data is intercepted midpoint, it's unreadable. Data is encrypted using an algorithm which sets the key type. A public key exists at the source, and associated private keys are available at the destination. The infrastructure relies on a set of certificates which contain all the relevant information, key combinations, authorized hosts, and more. These certificates ensure that source and destination are known and can be trusted. They guarantee that data can only be decrypted by the right parties at both ends of the data exchange. Automic Automation works with 3 types of certificates. An organization must decide which type is best suited to its needs. A certificate is always signed to guarantee its authenticity. The question then becomes, who does the signing? Automic administrators can sign their own certificates. It's fast, easy, and the data is always encrypted. This is fine from a technical perspective, but suffers a major security weakness inherent to the human organization. Without an independent signing authority, there's no control over the storage and protection of keys, and anyone with admin privileges can generate certificates and access encrypted data, including those who have left the company. Most IT companies reject this approach because it leaves the power to define the security architecture and then use it in the hands of the same people. Companies can set up their own certificate signing authority. We call this an internal CA. Your organization maintains a security team entirely disconnected from operations, whose job is to sign certificates. Administrators deploy certificates but have no control over the signing process. The roles are entirely disassembled. One group has oversight over securing the environments, the other is responsible for the Automic infrastructure. This is better, but it's not foolproof. There's still a risk of crossover and sharing of information between the 2 groups. Third-party signing authorities with no ties to the organization offer the best alternative. These are well-known commercial entities whose sole business is to sign their client certificates. They're highly secure corporate structures like GlobalSign, VeriSign, and so on. Their purpose is to make sure that the security provided by encryption cannot be bypassed internally. We won't spend too much time on this approach because they process signing requests differently. Deploying a publicly signed certificate is no different than self-signed. Let's consider the impacts of TLS SSL on the Automic Automation configuration. The database and utilities are not impacted because database packages like Oracle and SQL Server provide their own encryption mechanisms. The service manager is secured with CAPKI, and this has been the case going back several versions. The purpose of TLS is to secure communications between the automation engine and the agents, analytics, and the web interface. This being said, the entire process uses JCP and REST as gateways to the rest of AE. When deploying TLS, the only impacted process is the JCP. The others, namely CP, WP, and JWP, are not affected. The infrastructure requires a server certificate with the public-private key information. JCP and REST rely on this certificate to handle encrypted communications. All other components use signed certificates to connect to AE. All Java-based application agents require TLS SSL. Regarding OS agents, only Windows and Unix agents require TLS. Others, like VMS and ZOS, are not affected. In order to secure communications between TLS and non-TLS agents, Automic has created the TLS gateway, which we cover elsewhere. Let's talk about the process of deploying TLS. First, we look at the self-signed certificates. Several tools can do this, and we'll use KeyStore Explorer, which is open source and cross-platform. We generate a key store, which contains the public-private key pair. We store the key store on the AE host. Then we update ucsrv.ini for AE to use the key store. The key store name, public and private key passwords, and the alias, which is the name assigned to the key pair. Then we generate a self-signed certificate from the key pair. We store the certificate on the component hosts. Then for AWI, we have 2 options. We can either store the certificate in the Java Trust Store repository called CA certs. This guarantees that the certificate is usable by Java applications on this host. We can also update uc4config.xml and point to the certificate location using a trusted cert folder connections tag. The process for analytics is the same, we just update ucx.edda.ini. For Windows and Unix agents, we can either import their certificate in the operating system's trust store or update the agent INI with a certificate location. Finally, for Java-based agents, the options are the same as for the web interface, either CA certs or the INI. This is the procedure for internal CA certificates. This time we'll use OpenSSL, which is also free and cross-platform. We generate a CA root certificate. The certificate is now the authoring mechanism. Then we generate a certificate signing request or CSR. We use the CA root certificate and the CSR to generate the server certificate, which we convert to the PKCS12 format, making it a key store. The rest of the procedure is the same as for self-signs. The server certificate is deployed to AE using the same ucsrv.ini approach. The root certificate is deployed to the components in the exact same way as the self-signed certificates. Note that publicly signed certificates work the same way, except that we do not deploy the CA. We send signing requests using the authorities process and deploy the certificates as described earlier. Let's recap. We create a key store or server certificate and make it available to the AE host. These files contain the public-private key and the host information. This enables TLS for JCP and REST. AE can now process encrypted communications. We generate a self-sign or root certificate, which we deploy to the component hosts. This contains the public key information. It guarantees that they communicate securely with AE over TLS. These processes, in turn, handle the communications internally with the other server processes.